So we divide it by page size.
Okay. So now our page size is given 16 KB. So you can calculate the number of pages. So now if you know the number of pages, then you can calculate the number of frames. So after calculating the number of pages, how you will calculate number of frames? You will simply divide by in the same way. So this information is given. Length of the physical address is 32-bit. So if you know the number of pages in the virtual memory, then in the physical memory, main memory, you can calculate the number of frames. So you will divide by this with the number of pages. Now, if you know the number of frames, okay. So to uniquely identify this total number of frames, so you can calculate how many bits you will require. Okay. Now you will add 6 to this number. So this will be the total length for the page descriptor. Are you getting? Okay, Rohit Kumar is saying it is 24 bits. Okay. Any other answer? Okay, so we know the length of the virtual address not 6 multiplied by 18. If your 6 is the this 6 is you are referring to the additional bit for, yes, then 6 plus 18. If this 18 is the number of bits required to identify the frames, yes, then these two are same. 6 plus 18, 24 bits, 3 bytes. Okay, so let us calculate. Length of the virtual address is given. Okay, this is 38. So let us give some name. So 38 bits means 38 number of bits. So 2 to the power. Okay. So this information is given, and the page size is given. Length of the physical address is also given, so we'll use this one. So also 32. Now you can calculate the total number of pages in the virtual memory. Okay. How will calculate?
So
We know,
2.32 by 16 KB.
yes. So we'll simply divide. So we know we have total. So we are calling n this one. Okay. To identify, we can also call it here. So page size is 16 KB, means
2 power 14.
yes, 2 to the power 14. So 2 to the power 4 is 16, and from KB to bit 2 to the power 10. So total 2 to the power 14. Okay. So we can represent this as, so this is this 14 we will use. So we need this 14 bit. Okay. So you can represent this as 2 to the power some other number. You, so number of pages will divide this. Uh, 2 to the power 38 divide 2 to the power 14. It will give us 2 to the power 24. Okay. Now you calculated number of pages in the virtual memory, so you can calculate number of frames. In the physical memory. So how we will calculate? So in physical memory we have 32. Divide by, we calculated this to the power 24. So it will give us 2 to the power 18. 32, 24.
So, we'll divide 2 by 14, right?
Yes, that's why I am waiting patiently. Okay, so now you calculated number of frames. So you can find the, so for 18 plus 6. So those two answers are correct. So you can say page descriptor equals frame number plus additional parameters. Okay. Any question, anyone? We are going slow for everyone. So is it okay for everyone?
Yes, sir.
That means 3 byte. Now the second question is, what is the maximum size of page table? Have you calculated, Banani, Rohit?
Yes, sir.
Yes. So this is 3 byte, 24 bit. So the second question is maximum number of size in the page table. So 3 byte is needed for the page descriptor. So this many space is needed to identify every frames. Okay. a particular memory location from the main in the main memory. So how we will calculate maximum size in the page table? Simply p byte multiplied by which one? How many? Rohit, replay. Anyone replay?
Sir,
So two.
it will be 2 to per 3 bytes, right?
Okay. So for page descriptor, we need this much. Okay. So how many number of pages we have?
2
স্যার বলছি
per
পেজ সাইজ
24.
তো 16 KB ছিল, তা ওটাকে বাইটে নিলে 2 to the power 24 হচ্ছে।
হ্যাঁ,
হ্যাঁ
এতগুলো
স্যার।
পেজ আছে, টোটাল নাম্বার অফ পেজেস।
না স্যার, ওই তার উপরের লাইনে তার আগেরটা, দ্য পেজ সাইজ অফ 16 KB
হ্যাঁ
ইকুয়াল
স্যার,
টু
একটা ভুল হয়ে গেছে।
2 to the power 4 ইন্টু টু টু দি
ওটা
পাওয়ার
আমরা
10 হবে স্যার, ওটা বিটে করছি, ওটা বাইটে করলে 2 to the power 10 হতো।
হুম,
2 to the power 20 হবে স্যার, 10টা।
ইনটু 2 per 3 আরেকটা হবে।
KB. So 2 to the power 4 is 16 KB. So it is B.
8.
This one?
স্যার ওটা 2 to the power 24 হবে।
এটা যদি আমি বিট রাখি তো ঠিক আছে, তাই তো? বাইট রাখি।
বাইট রাখলে 2 to the power 14 ঠিক ছিল, কিন্তু আমরা বিটে করছি তো ক্যালকুলেশনটা।
না,
ওকে।
বিটে করলে তো 2 per 17 হয়ে যাবে। মানে ইনটু 8 হয় না?
হ্যাঁ স্যার।
স্যার, শুধু আরেকটা 2 per 3 একটা মাল্টিপ্লাই করে দিলেই হয়ে যাবে।
16 KB to the power 4 16 KB to byte to the power 14. Okay. Change it to B. Okay. No need to change anything. Now it is okay. Rohit. Hello. Banani.
স্যার, ওটা 2 per 14 বাইটস হচ্ছে। ওটাকে বিটসে চেঞ্জ করলে 8
টু টু দি
দিয়ে
পাওয়ার
মাল্টিপ্লাই
17।
করব।
হ্যাঁ, এটাকে আমি কেবি বিটাকে স্মল করে দিলাম,
ওকে,
below bit.
এবার ঠিক আছে।
হ্যাঁ
এবার
স্যার,
ঠিক
তাহলে ঠিক
আছে।
আছে।
Now this one. তাহলে এবারে কি করে ক্যালকুলেট করবে? ম্যাক্সিমাম সাইজ। So number of pages 2 to the power 24 multiplied by these 3 byte. So page table in bytes. So maximum size of the page table equals this one multiplied by 3 bytes for every So it will give us to the power 24 3 byte বাইটেই বলেছে তো আর কিছু করার দরকার নাই simply okay you can convert it to megabyte but this is in byte. So in megabyte it will be from 24 we can calculate 2 to the power 1 2 to the power 10 for kb and another 2 to the power 10 for mb. Okay, so 2 to the power 4 multiplied by 3 megabyte. This one, is it okay?
Yes, sir.
Now this problem is simplest problem we can say. Everyone should answer this one. You give it a try. I will take a break for 2 to 3 minutes. Okay. So Rohit, answer for A.
Sir, 2 to power 18.
2 to the power 18 কি? So this one address space.
Sir, bits বলছিলাম bits.
Yes. So for address space simply we have 18-bit address bus because here we have 18 signals for the address. 18 number of signals it can generate this mini computer. So with these 18 signals means 18 bits high or low. So this would be 2 to the power 18. So from bit you can convert it to KB. So 2 to the power 10 multiplied by
256.
yes. So 2 to the power 10 plus 8. So 2 to the power 8 equals 256.
KB.
For B
32 KB.
how?
Oh no. Bytes. Sir, sir, I just converted from bits to bytes.
Okay. See, it is given that 1 byte for every memory location. Okay. So how many number of memory location it can address? 2 to the power 18
Yes.
multiplied by 1 byte. 2 to the power 18 is the number. This many number it can address. And for every address in memory location we have 1 byte. So 2 to the power 18 multiplied by 1 byte means 2 to the power 18 byte.
Sir, actually, the 2 to power 18 was in bits.
No. The bits, yes, it is bits means 18 number of signals. Okay. So 18 number of signals we can represent 18 bits using 18 number of signals. Okay. So using 2 to 18 number of signals we can address 2 to the power 18 number of memory addresses. And in every memory address in the space physical memory
Okay, sir, understood,
we have
understood.
1 byte. Okay, this is the length for memory, and this many number we can address. So multiplied by 1 byte, this is the this means to the power 18 byte. Number C, Rohit.
Sir, 18. Sir, it needs
18.
to hold one address, so 18. 18
Okay,
bits.
18 bit. Yeah. Okay, so program counter. So in program counter we will place
The
address
address of next instruction.
next instruction. So essentially we are keeping address. So this computer to generate address it will use 18 signals. So program counter length will be simply 18 bit. Last one. So here we want to increase the address space by 8 times. So currently, right now, the address space is 256 KB, means 2 to the power 18. Okay. So 2 to the power 8. So 2 to the power 18 KB. Now we want to increase it by 8 times. Okay. So if we want to increase this 8 times, that means we need to increase this total number of signals. Okay. So the question is how we will achieve, how we can increase the address space by 8 times. So then we need to increase the total number of signals. We have right now we have 18 signals. So how many signals we will need?
So for three minutes, so
Yes.
three signals for
Three
8
or
bits.
yes. So three more signals we will need. So 8 means another with three signals, 2 to the power 3 equals 8. Okay. So if we increase the address signal from 18 and we will add another 3. So 21 total number of address signals will be, and in this question if we say for PC, so length of the PC will be instead of 18, 21. So here also we will increase the PC by 3 bits, length of the PC. Okay. So these changes we will need to incorporate, and obviously all other conditions, suppose to generate the syntax in the instruction format, will change the all the instruction formats according to this 21 bit. So this is the very simple example, but this concept you will need to know. You already know. So any question? Anyone? Okay, so today we'll end here with these two problems. Yes. Roll number 61. Roll number 61. Roll number 62,
স্যার 61 আছে প্রেজেন্ট, ওর মাইকে একটু প্রবলেম হচ্ছে।
62, Sagar.
Present, sir.
61 present, 62 present, 63,
Yes, sir.
64,
Present, sir.
65,
Yes, sir.
66,
Present, sir.
67,
ইয়েস স্যার।
68,
Present, sir.
69, 70, Aman, 71, Deepak, 72, Sneha,
Yes, sir.
74,
Present, sir.
75, 75, 76,